What's up everybody, and welcome to a new video. And in this video we continue to go over my notes for classes in Python. So in the previous video we've covered that classes add an additional layer for structuring code. We've also seen how to use classes, and we've covered the basics of creating classes. So now let's get to the somewhat more advanced topics, and the first one here is the init method. Namely, the purpose of that is to create instances with a customized initial state, i.e. to initialize them with specific values for the instance attributes. So for example, with our current class definition here, each instance that we will create will have the same attributes here. So for example, if we create here multiple instances, so if we say here ship1 and then also ship2, then both of these ships here will have the same values for these attributes here. So for example, if you look at the x, so if we say here ship1.x, then this is 0. And if we say here ship2.x, this is also 0. So now if we want to change those x and spread out those ships here across the screen, then we would have to do that manually. So then here we would for example have to say that the x of ship1 should be 1, and maybe the x of ship2 should be 2. So that's one way of doing it. However, a better way would be if we could initialize those ships here directly with those desired values. And that's exactly here what this init method is for. Then the next note states here that the init method is a special method indicated by double leading and trailing underscores. So if you want to create this init method, then what we have to do here is to say the following. So def and then underscore underscore init and then again underscore underscore. And then here you also have to pass then a self. So then what is special about init? The first thing that is special is that it's run automatically when an instance of the class gets created. So to show that, let's simply insert here a print statement. So you're going to say init is run. And then here, when I create here those two instances, then you can see that we get here those two print statements that say init is run. So as you can see, this init function is automatically run when an instance of a class gets created. And then the next thing that is special about init is that the parameters of this method, so to say, become the parameters of the class. So to show that, let's add here some parameters. So let's simply add here an x and a y. And then let's also print out those parameters. So let's say print x and then print y. And now if we try to initialize our variable or instances here, then you can see that we get now here this error because the init method here is missing two required positional arguments, x and y. So now when we create those instances, we actually have to specify x and y. So then here for ship1, let's say that x should be 0 and y should also be 0. And for ship2, let's say that x should be 1 and y then should also be 1. So now if I run it like this, then again we get here our print statements. So for ship1 we have init is 1 and then 0 0, and for ship2 we have init is 1 and then 1 1. And now what we can do with that is that in this way then you can use init to initialize instances with customized instance attributes. So for example, to show that, here instead of using these print statements, what you're going to say is self.x. This should be equal to x, so to this parameter, also this argument that we then here provide. And then the same thing for y, so self.y should be equal to y. So then, because we are creating here x and y, we don't need them here anymore. And now let's again run or create our instances. And because now we have used this approach, we have now initialized those instances here with customized values. So for example, let's look at the x of ship1. So let's say ship1 dot x. Then we get here a 0. And now let's do the same thing for ship2. So if we look at the x of that, then we have here a 1. So as you can see, we've now here initialized those instances here with customized values. So now let's get to this side note here, which simply states that you can of course also specify instance attributes without using the parameters of the init method. So you can also specify instance attributes without using here those parameters. So for example, let's create here another parameter and let's call this shared, and let's set that simply equal to true. So in this case then, each instance will then have here the same value for this shared attribute, another customized value. So to show that, let's create here again our instances, and then let's say here ship1 dot shared, so this is true, and then here for ship2 dot shared, you can see that this is also true. So that's a side note here that I want to cover. And with that, now we've covered here all my notes with respect to the init method. Then the next note is about class versus instance attributes. And here, the first note states that class attributes belong to the class and thereby indirectly to each instance, i.e. all instances have the same values for these attributes. So for example, in our class here, let's for now get rid of those two methods here. Here, those first attributes here, the points and the speed, those are class attributes. So each instance is going to then have here the same values for these attributes. So each instance is going to have here 10 points, and each instance is going to have here a speed of 1. So for example, to show that, let's for example use the points. So let's say here ship1, and then want to see here the points. So here then we have 10, and then also for ship2, if we say here points, then we can see that they also have here 10 points. So those are class attributes. Then the next note states that instance attributes belong to the individual instance, i.e. each instance can have unique values for these attributes, and those instance attributes are defined here within this init function. And in this particular case here, we can get here unique values for x and y, because for those attributes here, we are using here these parameters that we provide here to this init function. So then here, if we look at the x of ship1, then we can see that this is 0. And if we look at the x of ship2, then we can see that we here have actually then a 1. So those are then instance attributes. Then the next note states that when trying to access a specific attribute, Python first checks the namespace of the instance, and if it can find the attribute, then it looks at the namespace of the class. And you can access those namespaces with a special attribute. Namely, if I say here underscore underscore, and then invoke here IntelliSense, then we get here these special attributes. And the one that we want to look at here is this dict. So if I run this, then we get here this dictionary, which contains the namespace of that instance. So here we can see for ship1, x and y are 0, and the shared is set to true. So now let's do here the same thing for ship2. So if I run it for that, then we can see x and y is 1, and the shared is also true. And we can also use here the special attribute for our class here. So if I say enemy ship and then use this special attribute, then we can get the namespace of our class. So here we can then see those attributes, points and speed. So now when we say, for example, something like ship1.x, what Python is doing is first checks the namespace of ship1. So it looks here at this namespace. And then if it can find the respective attribute, then that's then the value that it will return. So in this case, we find here this x, and here the value is 0. So therefore then it returns here a 0. And this is also the case if we would have here an x in our namespace of our class. So for example, if I create here an x and say here simply, or let's set that to 99, and then run those cells again, then you can see now here in our namespace of the class, we now have this x. However, if I here run ship1.x again, then we still get the 0 because Python finds here this x in the namespace of the instance. So now let's look at here another example. So let's say ship1.points. So in this case again, Python first checks the namespace of the instance. So in this case, it can find here the points. So therefore then it goes to the namespace of the class. And then here it finds the points. So therefore then it will return here a 10. So this is how Python checks the different namespaces of the instances and the class. Then the next note states that depending on the use case, you might want to modify instance attributes or class attributes. And now to show what I mean by that, let's create here a new method. So let's call this here increase speed. And then here again, we put in a self. And then here, let's first look at an example where we try to modify instance attributes. So in that case, then if you want to modify the instance attribute, then we would say here self.speed. And let's say we want to increase that by 1. So we're going to say plus equals 1. So now let's see how this method here behaves. So therefore, let's here simply print out first the speed of ship1. So we're going to say ship1.speed. And here, as you can see, this is 1. So now let's run here this method and then print out this the speed of ship1 again. So we're going to say ship1 and then increase speed. And then let's print out also the speed of ship1. So here then you can see that we've increased it by 1 and now the speed is at 2. So now let's also look at the speed of ship2. Namely, so if we say here ship2.speed, then we can see that this here is still at 1. And we can look at the namespaces of here our instances in the class to understand why this is happening or why this is working in this way. So let's first look at the namespace of ship1. So we're going to say here dict. And then here you can see that here we have actually created here now an instance attribute, which is also called speeds, when we ran here this increase speed method. And if we look here at the namespace of ship2, so ship2 and then the dict, and then here we can see that here we don't have this speed attribute. So therefore then in this case here Python checks then the namespace of the class. So if we look at that, then we can see that here the namespace looks like this. So here we then have the speed. So that's why we get here for ship2, we get a speed of 1 because this hasn't here changed. Okay, so that is an example when we want to change the instance attribute. And now let's look at an example where we actually want to modify the class attribute. So in that case, here instead of saying self.speed, what we do is we simply say enemy ship.speed. So now if we define it in this way, then what happens is the following. So let's first look again here at the speed of ship1. So this is still 1. Then let's here run this method and then again look at the speed of ship2. So this is still 2. And now, however, if you look at the speed of ship2, then we can see that this has also changed to 2. And again, we can look at the namespaces to see why or to understand why. So if we look at the namespace here of ship1, we can see now this time we haven't here created an instance attribute, which is called speed. So therefore then Python checks here the namespace of the class, and here it can see that the speed is 2. So therefore then here in both cases for ship1 and ship2 we then get here a 2. So this is what I mean by this note here that says depending on the use case you might want to modify instance attributes or class attributes. So now let's get to this side note here, and this states that class attributes are evaluated at the class definition and not when the class is called. So to demonstrate what I mean by that, let's say here I equals 5, and then let's here create another class. So let's call this class here simply my class, and here we're going to create class attribute x, and we set that equal to I. So then let's now here create an instance of that class. So we're going to say instance equals my class. And then let's here also print out instance.x. So if I run this, then instance.x is 5. So nothing unexpected. However, if I now, for example, set here I equal to 6 and then run here this instance creation again, then you might think now in this case, x should be equal to 6 because here in our class we say that x should equal I. However, if I run it, then you can see that it is actually still 5. And that's because, as I said here on this note, in the side note, class attributes are evaluated at the class definition here. So therefore then, if I run here this class definition again, and then create here an instance, then we can see that now actually x here is equal to 6. So to explain what's going on here, I've prepared this illustration here. So let's open that. And then let's have a look. So what's going on here? At first, when we say I equals 5, is that the 5 is created, stored in a specific place in memory, and then I points at that place in memory. And we can check that out here by printing the ID. So print the ID of I. So in this case, we get here this ID. Then here in the next cell, where we create here this class definition, what happens is then here then the myClass.x should simply point at whatever I is pointing at. So since that is pointing at 5, my class.x is also then here pointing at this 5. And we can check that out by printing out that x. So we're going to say print my class.x. So here we can see that it's 5, and let's now also print out the ID. So we're going to say here print the ID of that. And here we can see that this ID and this one here is the same. So both are pointing at the same object in memory. So then in the next cell here, where we create here this instance, what happens is that here we say that this instance.x should point at whatever my class.x is pointing at. And since that is still pointing at 5, instance.x is also pointing at 5. And then therefore then here we print out this 5. And now we can also verify that by printing out the ID. So let's again here print instance.x. So we're going to say print, and then let's also print out the ID. So let's here again run the ID. So here we can see instance.x is 5, and we get here the same ID. So all of these attributes or variables are pointing at the same object in memory. So then next, when we say here I equals 6, what happens is that 6 is created, stored in a specific place in memory, and then I points at that place in memory. And again, we can verify that by printing out the ID. So let's say print ID of I. So now we get here a different ID. So this is now different than the IDs that we had here before. Then in the next cell here, where we create an instance, in this case, then what we say is that instance.x should point at whatever my class.x is pointing at. And since that is still pointing at 5, then this instance.x is also pointing at 5. So that's why we get here this 5. So therefore, let's again print out also the ID. So if you look at that here, the ID is still the same that we had here before. Okay, so then next we then again run here this class definition. So in that case, then what we say is that my class.x should point at whatever I is pointing at. So since that is now pointing at 6, my class.x is also then pointing at 6. And again, we can verify that by printing out my class.x and the respective ID. So let's do this. So here it now prints out here 6. And we have here now this new ID that we also have here for our I. And then in the last step, so in this last cell where we run again, or where we create again our instance, what we say that instance.x should now point at whatever my class.x is pointing at. And since that is pointing at this 6, instance.x is also then pointing at this 6. So let's again here print out also the ID. So now we can see instance.x is also pointing at the same ID as my class.x. So therefore then in this case here we get a 6. Okay, so that is then this side note here that I wanted to cover. And with that now, we've covered all my notes with respect to this note here, which is about class versus instance attributes. Then the next note is about inheritance. And here, the first note states that inheritance lets a child class inherit the attributes and methods of its parent class. i.e., if you want to create a derivative or variation of a class, then you can simply reuse its class definition instead of copy-pasting entire code blocks. So to show what I mean by that, let's again use here our enemy ship class. And let's say that this is going to be our parent class. And now we want to create a child class from that. So therefore then we simply say here class. And then let's call this class here boss ship. And then to inherit here from this parent class, what you do is you create your parentheses, and in those parentheses you put the parent class. So in our case that would be then the enemy ship. And then here for the code block, let's simply put in here a pass for now. So with that now we've created here this child class. So now let's create an instance of this child class. So we're going to say boss equals boss ship. And then if I try to run it like this, then we get here an error because we have to specify the arguments x and y that we've inherited here from the parent class. So therefore then here we also say x equals 0 and y equals 0, for example. And now if I run this, then we create our instance. And then here, even though we haven't written any code for our child class, we still inherited all the attributes and methods of our parent class. So for example, what I can say here is, for example, to say boss.points. So then here we get this 10. So we accessed here this class attribute of our parent class. And we can also access here, for example, this method. So if I say here boss.shoot, then you can see that it prints out here shot fired. Okay, so this is then how you can create a child class that inherits the attributes and methods from a parent class. And here, just a side note, the child class here could also be called a subclass or derived class, and the parent class could also be called a superclass or base class. So that's here the first note that I wanted to cover. Then the next note is about adding additional attributes or methods to the child class. And you can simply do that by putting them here into the class definition of the child class. So to show an example for that, I've prepared here this code snippet. So here we create a class attribute called addMissiles, and then here we define here this method which is called fireMissile. So now if I then create here this boss ship, and now let's try to access those attributes and this method here. So therefore then we simply say here boss.addMissiles, and then you can see that we get here 10. And now let's also access the method. So therefore we're going to say fireMissile, and then here it prints out missile fired. And then here obviously this class attribute and this method here is not available for the parent class. So for example, if I say here, if I create here a ship, so let's say this is then an enemy ship, X should be equal to 0 and Y should also be equal to 0. And now if I try to access here, for example, this attribute for our ship, then we get the following. So if I say a ship and then addMissiles, in this case, then we get here an error because the enemy ship object has no attribute addMissiles. Okay, so this is then how you can add additional attributes or methods for the child class. Then the next note is about overriding attributes and methods of the parent class. So to demonstrate that, let's for example say that we want to override here this class attribute points. Namely, what we'll do is here for our boss ship, we actually want to set that to 100. So to do that, you simply say here points and then 100. And then let's also say that we want to override here this method. So let's copy and paste that. And then here, let's say that this boss ship can actually fire 3 times. So therefore, then here we say 3 shots fired. So then if I now run the definitions like this and then create here our boss and the ship. And now let's print out first here the points for both. So we're going to say print boss.points, and then also the same thing for the ship. Then you can see that the points for the ship are still 10. However, for the boss ship, they are now set to 100. So we've overwritten here this class attribute. And now let's also do the same thing here for the shoot method. So therefore then here, let's say ship.shoot. Then here it prints out shot fired. However, if we do the same thing for the boss ship, so if we say boss.shoot, then it prints out here 3 shots fired. So this is how you can override the attributes and methods of the parent class. Then the next note is about accessing the attributes or methods of the parent class via the built-in function super. So to demonstrate that, let's say here for our fireMissile method of our child class, let's say that this should also make use here of the shoot method from the parent class. So to do that, what we need to do is to say here super and then dot shoot. So this way then we can access here the shoot method from the parent class. So let's see if that works. So therefore then here, let's simply say boss.fireMissile. And now if I run this, then you can see that it says here missile fired and also shot fired. So that is how you can access a method of the parent class. So now let's look at an example where we want to access here an attribute of the parent class. And to show that, I've prepared here this method. So let's paste this. So this is called getHit. And here what happens is that it simply prints out that the player gets a certain amount of points. And let's say that amount should be the same amount that the player would get when the player shoots down an enemy ship. So we want to get here these points. So therefore then we simply say again super and then dot points. And now let's see if this worked. So then here we're going to say getHit. And now if I run this, then you can see that it says here the player gets 10 points. So we've accessed here in this method this attribute here from the parent class. And now, just as a side note, one thing that you also might want to do is the following, namely to create here an init function for the child class. So in this case, then here we specify the parameters x, y, and level. And then let's say one thing that you might want to do is here to say self.x equals x and self.y equals y. However, you can do this here more succinctly, simply by calling the init method from the parent class. So to do that, what you say is then here super, and then you call this init class, init method. So we're going to say init, and then here you can pass in the x and the y. So now if you run it like this, then here we have to also specify the level. So let's say here level of the boss ship equals 5. And now let's see if this init function here of the boss ship worked. So therefore let's simply look at the x. So boss.x and then also boss.y. So as you can see, this has worked. Okay, so this is how you can access the attributes or methods of the parent class via this built-in function super. And then here I also have a side note, and this states that you can also access the attributes or methods of the parent class by directly calling it. So what I mean by that is the following. So here, instead of using this super function here in all of these different places, what you also can do is simply call here this parent class. So if I then say here enemy ship, then we can also access the attributes and methods of the parent class. In this case then, however, here for the methods, you first then have to provide the self as this parameter here. So for this init function, and then also here for this shoot function. So now let's run the code like this and then see if it works. So again, if I print out here the x and y, then you can see that we get here both 0. And then let's also check out here this got hit method, where we then call here this points attribute from the parent class. So let's say then here boss and then got hit. And then if I run this, then you can see that it prints the player gets 10 points. So this worked. And then let's also check out this fire missile method, where we call here the shoot method from the parent class. So then here, let's say boss fire missile. And then if I run this, then you can see it prints out missile fired and also shot fired. So as you can see, you can also simply directly call the parent class to get access to the attributes and methods of that parent class. However, in most cases, it is actually recommended to use the built-in function super. And this is especially true when using multiple inheritance, which we talk about here in a moment. However, there's one exception to that, and that exception is when you want to change a class attribute. So in that case, you actually have to call the parent class directly and not use here this super function. So to show that, let's say that here for our boss ship, we want to create an attribute that is called speed. And we want the speed of this boss ship to be twice as fast as the speed of the enemy ship. So therefore then we might say here 2 times, and then here we want to access here the speed of the enemy ship. So what you can do is to say here super and then dot speed. Namely, if I try to run it like this, then we get here a runtime error. So in that case, then you actually have to call here the parent class directly. So if I say here then enemy ship dot speed, then we don't get an error here. And then let's also here look at the speed of our boss ship now. And then here you can see that it is 2 and it is not 1. So here this has now worked, where we try to access this speed attribute from our parent class. Okay, so that's the side note here that I wanted to cover. And with that, then we've covered here all my main notes with respect to inheritance. So now let's get to the side note here. And this is about multiple inheritance. Namely, a child class can inherit the attributes and methods of multiple parent classes. So to demonstrate that, I've prepared here these classes. So here we have class A, B, and C. Class A has the attribute X, class B has the attribute Y, and class C has the attribute Z. So now let's say that we want here this class C to inherit both from A and from B. So to do that, we simply put in here the parentheses, and then here within the parentheses we specify all the parents that this child class should inherit from. So in our case this would be then A and B. So now let's run this, and now let's create an instance of C. So let's say your instance and then C, and now let's print out all of these attributes here. So let's say here then print instance.x, and then also the same here for y and for z. So now if I run this, then you can see that it prints out here 1, 2, and 3. So this is how a child class can inherit the attributes and methods of multiple parent classes. Then the next note states that when super is used, then it adheres to something called the method resolution order. And to show what that means, I've prepared here this code snippet. So here we have 4 classes, class A, B, C, and D. D is a child of C and B, and C and B in turn are then a child of A. So we have here this diamond structure where A is at the beginning, at the top, then B and C, and then at the bottom there is C. So then here each class also has a method, and in that method we simply print out the name of the class. So for class A we print A, for class B we print B, for class C we print C, and so on. And then for each of these childs here, then we call here the method of the parent class. So now let's create here an instance for class D. So we're going to say here equals D. And now let's call the method. So let's going to say instance.method. So let's run this. And then here you can see that it prints out D, C, B, A. So what's happening is here, when we call the method of this instance of D, is we print here first the D. So that's why we get here the D. And then here we call the method of the parent class. So we call the methods here for B and C. So therefore then it prints out here C and B. And then in both of these classes, then, however, we call here the parent or the method of the parent class, so of A. And even though we call this here twice, A is only printed once. So that is what this method resolution order here does. And now let's see what happens when we don't use here this built-in function super, but instead call the parent classes directly. So for example, here then we have to say A. So A is the parent class of B, and then here as well. So let's also say here A, and then here for D, however, now we have 2 parents, so then we have to decide which one we're going to pick. So let's first start here with B, and then because we are now calling those classes directly, we have to actually put in here a self in those method calls. So let's say self, and then here also. So now let's run this and see what happens. Namely, in this case, it only prints DBA. So we don't print C because we are not calling the method for C here. So therefore then, if we say, for example, then here, if we say C, then it prints DCA. So therefore then we are not printing out the method for B. So therefore then, if you would want to access everything, then we would also need to call here B. So let's say then B and see what happens in this case. Namely, then here you can see that A here gets printed twice. So this is what then this super function here does. And this is also then why you should use here the super function when using multiple inheritance. Okay, so with that now we've covered here multiple inheritance. And with that then we've covered here all my notes with respect to inheritance. So therefore then we have covered here all the advanced topics. And therefore then we have covered here all my notes with respect to the classes in Python. So we've reached the end of this video. So then in the next video, we will go over my notes for modules and packages in Python. So thanks for watching, and hopefully I will see you in the next video.